Okay, chapter 6, benzene and its derivative. So, benzene is an example of aromatic compound or also known as arene. So, benzene is only one of the example. So, there are so many aromatic compounds. So, one of them is benzene. So, what is aromatic compound? So, aromatic compound is a structure that is cyclic, conjugated, unsaturated molecule that is stabilized by pi electron delocalization. What does it mean by pi electron delocalization? It means that electron at the pi bond can move around. Okay, we will look this one later. So, according to Kekulé structure, okay, so this is the structure of benzene expanded. So, there are 6 carbon and 6 hydrogen. Okay, so if number of carbon and hydrogen the same or almost the same, it means that it has benzene ring. Okay, because number of carbon and hydrogen the same or almost the same. It's not 2 times. Okay, so this is expanded structure. So this is skeletal structure. Okay, according to Kekulé. Okay, so if you look at the structure, double and single bond is alternating. So you have double here and then single and then double, single, double, single. So double and single will be alternating. So when you want to draw a benzene ring, so we will start with cyclic. And then when you want to draw double, you can start here and then double, single, double, single, double, or you can start your multiple bond here. Okay, double, single, double, single, double, single. So both is benzene ring. Okay, you can start here or maybe you can start here. Okay, so this electron can move around, can be delocalized. Okay, so this double bond can move here, so you will get this double bond. So when this bond move here, so this bond will move here, so you will get this double bond. So this bond will move here, so you will get this double bond. So electron at the pi bonds can move around. So that's why we can draw like this, resonance hybrid. So you can draw circle. The circle will represent 6 pi electron distributed over 6 atoms of ring. Okay, why electron at pi bond can move around? Okay, so for pi bond, in order to make pi bond, p orbital will overlap side to side. Okay, so for example, this pi bond, so p orbital will overlap side to side. Okay, so this pi electron, so p orbital will overlap side to side. And then same goes here. So the p orbital will overlap side to side. So these two electrons can move here. Okay, so this electron move over here, so this electron move over here. So the two blue electron, this one will move here, so this one will move here. And then same goes to this one. So that's why the pi bond can electron at the pi bond can move around. So in conclusion, when you want to draw benzene, you can draw like this, or you can draw like this. So these three structures represent benzene. Okay, so next, why benzene is an example of aromatic? What makes benzene as an aromatic compound? So basically, there are 4 criteria for aromaticity. So these all 4 criteria must be obeyed. Okay, so benzene has these 4 criteria. Okay, kalau tak cukup satu, tak boleh jadi aromatic lah. So ini adalah kriteria nak jadi aromatic. Okay, so the first one is cyclic. If it is cyclic, it will be planar. So planar means that all atoms in the molecule lie in the same plane. So planar means flat. Okay, so this is carbon, 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 carbon. The red one is hydrogen. So it is flat. Okay. So next is completely conjugated. Okay. So completely conjugated means that delocalized electron in compound with alternating single and multiple bond. It must be alternating single and double. So double, single, double, single, double, single. Double, single, double, single. Okay, same goes to this one. So it means that it is completely conjugated. Okay. So the last one is Huckel rule. Number of pi electron must satisfy Huckel rule. So Huckel rule is 4n plus 2 equal to number of pi electron. So n will be equal 0, 1, 2, 3 and so on. So n cannot be in fraction or decimal places. Okay. So we check for benzene. Okay, so benzene is cyclic. If it is cyclic, it's planar. So benzene is completely conjugated because the single next to double, single next to double, single next to double. So we need to check whether benzene obey Huckel rule or not. So according to the formula, for n plus 2 equals to number at pi electron. So if we look at benzene, there are 3 double bond. Okay, there are 3 double bond. So 3 double bond means that you have 6 pi electron. So number of pi electron is 6. Okay, so n will equal to 1. So n equal to 1 is allow. Okay, so it is obeying Huckel rule. So this compound is aromatic. Okay. Okay, if you look at this one, so it is cyclic. It is planar. It is completely conjugated because double and single bond are alternating. Okay, so we check whether it's obeying Huckel rule or not. So here you have 2 double bond. So pi electron is 4. Okay, so n is equal to 1 over 2. So this is disobeying Huckel rule because n cannot equal to half. Okay, so this compound, okay, is non-aromatic. Okay, okay, for this one, so this cyclic, it is planar, it is completely conjugated, and this one obey Huckel rule, so you can calculate by yourself. So this one is n equals to 3. So this one is aromatic. Okay, so this one is okay, the last one. So this one is cyclic. This one is planar. This one is completely conjugated. This is not single, single, single. Okay. Why? Because if you look at here, so double, single, double. Okay. So this single bond consists of this carbon and this carbon. So next to this single bond is this carbon. So this carbon has double and also single. So single, double here. Okay, not single, single, single. Okay, so single bond here, double here. Okay, so double, single bond here. So it will get double here. Okay, so this single bond, okay, is being made from these 2 carbons. Okay, so this carbon has double. Okay, so single and double still alternating, still next to each other. Okay, so if we calculate pi electron, so for n plus 2 equal to number of pi electron, 2, 4, 6, 8, 10, 12, 14. So for n plus 2 is equal to 14. So n will equal to 3. So this one is obeying Huckel rule. Okay, so it is aromatic.